The next type of binomial that we need to consider factoring are called perfect cubes, or factoring cubes, binomials that are cubed. Now, to do this, we really need to be familiar with at least the first 5 perfect cubes. In other words, if I know that 1 times 1 times 1 is really 1, that's 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. That will help me factor these problems. Now let's take a look. Cubes are always going to be a cubed plus b cubed or a cubed minus b cubed. Now this is okay. We can factor a sum of cubes and a difference of cubes. They both will factor. The way they factor is written down for you in these 2 illustrations. But first I want you to go through an example with me, and then you can go back and see if the illustrations make sense. The first thing we want to do, and they always factor into a binomial times a trinomial, the first thing we're always going to do is set the signs. In a binomial and a trinomial, you will have 3 signs. 1, 2, 3 signs will always be there. The first sign is going to match the problem. I call that the M sign. The second sign will be the opposite of the problem, and the third sign is always positive. So, if you can remember the word mop, you can pretty much set the signs for your trinomials that you factor. Your perfect cube binomials that you factor. So, example 1 is x cubed plus 8. Now, I recognize that x cubed is a perfect cube. Why? The exponent is divisible by 3. And I know 8 is a perfect cube. The cube root of 8 is 2. That was one of the ones I told you to be familiar with at the top of the page. So I'm going to set my signs. I set a binomial times a trinomial. I need 3 signs. Match the problem, opposite of the problem, and positive. That's the way it always is. M-O-P. Next, I'm going to figure out what is this cube root of the A term. Now, the cube root of the A term, this is it. We've just really got A and B terms in these. The cube root is, what's the cube root of x cubed? Well, this time it's x. And what's the cube root of 8? It's 2. That's the numbers that I need to plug in to my first binomial pair, x and 2. So what did I do? I took the cube root of x for my first pair and the cube root of 8 for my second. After that, I don't have to worry about this problem anymore. I'm not going to look back at the problem. I'm only going to look at my binomial to set my trinomial. What do I do now? Well, I say, what is a squared? In other words, I'm going to take the first term and I'm going to square it. A squared is really x squared. B squared would be 2 times 2 or 4. Where do I put them? First and last positions. I take the first term and I square it. I take the second term and I square it. And I filled in my first and last positions. Now, what do I do for this middle position right here? Well, what I do is I multiply A times B. A times B is 2 times x, or 2x. 2x is what goes in the middle. And that is the factorization. The only difference in sums and differences of cubes is the signs. If you will always remember to match the problem with the first sign, do the opposite with the second, and always make the third one positive, then you don't have a problem setting signs. So let's look at another example. This one is a difference of 2 cubes. Remember, I'm checking. 27, the cube root of 27, I know that is going to be 3. And I know the cube root of 64 is 4. So I sort of check that first. The cube root of x cubed is x. If I were to square those, I would say 3x times 3x is 9x squared. And 4 times 4 is 16. And then when I multiply A times B together, I say 3x times 4 is 12x. I really have all the numbers I need to do the perfect, the binomial, the perfect cube, the cubes. Okay, to factor the cubes, okay? So what do? I'm going to set the signs. Match the problem, opposite of the problem, always positive. So match, opposite, positive. I've set my signs. Now I'm going to say the cube root of that first term, or A, is 3x. The cube root of the second term is B, and that's 4. I have created a binomial. Now I'm going to use this binomial to create my trinomial. Now I know we've already made notes below, but this is a way you can do it without having to write all these things down and remember which position they go in. What do I do for the first position? I take 3x and I square it. So I'm going to say 3x times 3x, 9x squared. What do I do for the last position? I take 4 and I square it. Now remember, you don't have to worry about the signs because you've already set those. 4 times 4 is 16. What do I do for the middle position? I multiply the two of those together and put it in the middle. 3x times 4 is 12x. If you want to memorize the formula, which is right here for you, and you want to fill in these blanks, which we've done down here, you can. But if you'll remember, you always take the cube root of the first term, make your first binomial position, the cube root of the second term for your second binomial, and create the trinomial from that binomial that you just created. It might be a little bit simpler. Let's do that when we do example number 3. First, check. Are they perfect cubes? What's the cube root of 125x cubed? Well, it would be 5 is the cube root of 125, and x is the cube root of x cubed. What about the b term? Remember, this is the a term, this is the b term. The b term, the cube root of 27, is really going to be 3. Remember, this is a cubed and b cubed, right? So what do I do with setting my signs? Well, I'm going to match the problem. Opposite, always positive. Now, I'm going to say the cube root of this first term goes right here. The cube root of 125, I've already found it, is 5x. The cube root of 127 is 3. Now, I'm not going to worry about the problem. I'm going to take these, square this one to come up with my first trinomial term. 5x times 5x is 25x squared. I'll take this one right here, the second term, and I'll square it to come up with my third trinomial term. 3 times 3 is 9. I multiply them together to come up with my middle trinomial term. 5x times 3 is 15x. And that's really correctly factored. Now, if you wanted to, like I said, there's your formula that has a difference of cubes with the signs correctly set. You can figure out what all these are and fill it in, or you can just create the binomial from the problem and create the trinomial from the binomial you just created. Let's try a couple more cubes, and this time I'm going to use the shortcut. Now look, first I look at this problem and I say, well, that's not a perfect cube because 2 is not a perfect cube, is it? But I do have a GCF. I can factor out the 2. I now have 2 times x cubed plus 8. That is a sum of 2 cubes. I'll set the signs, match the problem, opposite of the problem, always positive. I'll factor the a term. The cube root of x cubed is x. I'll factor the c term, b term, the cube root of 8 is 2. Now I want to take the first term and square it. X times x, x squared. I'll take the second term and square it. It goes down here in the last position. 2 times 2 is 4. I'll multiply the 2 together and put them in the center. X times 2 is 2x. Cubes are fairly simple to factor once you've memorized the procedure. Let's try this last one. Look first and see, do you have a GCF? Because, oh wait, I forgot to write the GCF on the last one. There's my 2. Okay, now look first and see if you have a GCF. First, I'm going to say, I don't have a coefficient of both of those, so the 27 is going to have to stay. I have x's in both, so I can factor out an x, and I have y's in both. I can factor out a y squared. So what is the binomial? 27 x cubed y cubed minus 1. Are they both perfect cubes? Well, 27 is, y cubed and x cubed both are, and 1 is a perfect everything. It's sort of like the Joker card. It's a perfect cube, a perfect square, a perfect everything. So let's set our signs. We look at this minus and we say match the problem, opposite of the problem, always positive. And now we're going to say, well, let's go ahead before I forget again and write down the GCF that we factored so we know it's there. Let's find out what the cube root of 27 is. We know it's 3. The cube root of x cubed is x, and the cube root of y cubed is y. The cube root of 1 is 1. I have set my first binomial. Now let's set the trinomial. Only looking at the one I just created. Don't look back at the problem, okay? So I'm going to square the first term. I'll square 3xy times 3xy would give me 9x squared y squared. Now let's do the last one. I'm going to square the second term, 1 times 1. And let's do the middle by multiplying the two together. Really, it's 1 times 3xy, which is just 3xy.